Hello everyone, and welcome to another video of the Mathematecher channel. Let's assume that we have 3 dice, a white one, a green one, and a red one, that we roll randomly to get from each of them a digit that we note as W for the white dice, and as G for the green one, and as R for the red one. After that, from these 3 digits, we form a number that we note capital N, such that the digit W that we got from the roll of the white dice represents the hundreds of the number capital N, and the digit G that we got from the green dice represent the tens of the number capital N, and the digit R from the red dice represents the units of this number. We're asked at first to find out how many possible numbers we can form from this procedure. Or in other terms, what are all the possible outcomes that belong to the sample space of this random experiment? Then, we would like to find out the probability of the event according to which we get a number that we note as capital A, such that the digits G and R are equal. After that, to find out the probability of the event according to which we get a number that we note as capital B, such that the digit W equals 5. And finally, to find out the probability of the event to get a number that we note as capital C, that is a square to a natural number. So let's begin. So, as each dice has in each of its faces either the digit 1, or 2, or 3, or 4, or 5, or 6, then when rolling the white dice, we have 6 possible outcomes for the digit W. Then, for each of these outcomes, when rolling the green dice, we have 6 possible outcomes for the digit G. After that, for each of these outcomes, when rolling the red dice, we have 6 possible outcomes for the digit R. So there are 6 times 6 times 6, which equals 216 possibilities for our number capital N. Let's now find out the probability to get the number capital A. So, to get the number capital A, which is characterized by the equality of the digit of its tens G, and the digit of its units R, we have 6 possible outcomes for the digit of its hundreds, W. For each of these outcomes, we have 6 possible outcomes for the digit of its tens, G. But now, as the digit of its units, R must be equal to the digit of its tens, G, we would have only one possible outcome to keep for the digit R for each possible outcome for G. Therefore, the number of all possible outcomes to get the number capital A equals 6 times 6 times 1, which equals 36. So the probability for this event to happen, that we note as P of capital A, would be equal to the number of the possibilities to get the number capital A over the number of all possible outcomes of this experiment. Therefore, P of capital A equals 36 over 6 times 6 times 6, which equals 1/6. Now, let's find out the probability to get the number capital B. So for the number capital B, of which the hundreds digit, W, equals 5, we have obviously one possible outcome to keep from the rolling of the white dice, which is 5. And for this outcome, we have 6 possible outcomes for the digit of the tens, G. For each of this possible outcome for the digit G, we have 6 possible outcomes for the digit of the units, R. So the number of all possible outcome for this event to happen equals 1 times 6 times 6, which equals 36. Therefore, the probability to get the number capital B, which equals the number of all the possible outcomes to get the number capital B, over the number of all the possible outcomes of this experiment, would be equal to 36 over 6 times 6 times 6, which equals 1/6. Now, let's calculate the probability to get the number capital C. So for this event, which is to get the number capital C, which is a perfect square, to happen capital C, which is written as W, G, and R, must equal the square of A, such that A is a natural number. Which is equivalent to say that the number A equals the square root of the number W, G, and R. Now, as all the possible values of the digits W, G, and R that we get from the dices are between 1 and 6, we deduce that the number capital C, which is written as W, G, and R, is between 111 and 666. So the possible values for the number a, which equals the square root of the number w, g, and r, are from 11 to 25, except the numbers 13, 17, and 23, because the squares of these numbers gives numbers of which one of their digits is strictly greater than 6. So from 11 to 25, excepting 13, 17, and 23, we would have 12 possibilities for our natural number a, which mean 12 possibilities for the square of a, which is the number w, g, and r, which is capital C. So the probability to get the number capital C, P capital C, which equals the number of all the possible outcomes to get the number capital C, over the number of all the possible outcomes of this experiment, would be equal to 12 over 6 times 6 times 6, which equals 1 over 18. As always, thank you for watching. Consider to subscribe to the channel if you're new to it. Like and share the video. And until the next one, have a great time.